what is the deep soil mixing used for. Deep soil mixing is an in situ ground improvement technique that enhances the characteristic of weak soil, mechanically mixing them with a cementation binder, and it also the action of mixing materials such as cement, fly ash, lime or bentonite with soil causes the properties of the soil to become more like soft rock. Deep soil mixing provides two types of deep soil mixing for geotechnical and environment application, including mass mixing and column mixing. Both systems offer wet and dry soil mixing solution which enable the additive to be placed as wet slurry or dry powder. They are able to tackle some of the most difficult soil conditions, ranging from fruit plains and soft soil through to contaminate land. Okay, let's go for the mass mixing. Mass mixing is used in situations where a whole area of very soft or contaminated ground requires improvement. And it also, the procedure involves mixing a cementation binder into peat, silt or soft clay and is carried out with a mixing tool that has been installed on an excavator machine. By mixing in both the horizontal and vertical direction, the substance combine to form a much improved structural quality material that in some instances can be used as fill. Mass mixing is applied at depth between 1 to 6 meter and application include mass stabilization of dragging mud, canal management, road construction, ground strengthening and light remediation. Okay, for the column mixing, soil mix column may be single or overlapping triple columns installed up to 23 meter in depth for installation or cut-off walls. It also to improve the bearing capacity of the soil, for example, or embankment at risk of soil erosion. Retaining wall for flood defense, shims, comfort dams, or any other purpose may be built economically using soil mixing if the ground conditions are suitable. Granular materials such as sand and gravel are mixed with cement slurry to form solid walls. Deep soil mixing uses a double auger system fitted with an innovative rubber rotary mixing head or a triple auger system fitted to a telescope radar rig.
Two technological advancements. First, mass mixing technology. Mass mixing is used in situations where a whole area of very soft or contaminated ground requires improvement. The procedure involves mixing a cementitious binder into peat, silt, or soft clay and is carried out with a mixing tool that has been installed on an excavator machine. By mixing in both the horizontal and the vertical direction, the substance combine to form a much improved structural quality material that in some instances can be used as a fill. Mass mixing is applied at depth between 1 to 6 meters and application include mass stabilization of dragging mud, canal management, road construction, ground strengthening and land remediation. Second, column mixing technology. Soil mix column may be single or overlapping triple column installed up to 23 meter in depth for installation of cut-off wall or to improve the bearing capacity of the soil, for example on embankment at risk of soil erosion. Retaining wall or for flood defense scheme, comfort dam or any other purpose may be built economically using soil mixing if the ground conditions are suitable. Granular materials such as sand and gravel are mixed with cement slurry to form solid wall.
First, the soil mixing can be performed to depth up to 100 feet and can conceptually be used for most subsurface condition from soft, plastic clay to medium density sand and gravel with clog. For the dynamic compaction, large lateral displacement 1 to 3 inch has been measured at distance of 20 feet from the point of impact by temper ranging 33 to 66 keeps any burnished surface or utilities with this zone of influence could be damaged or displacement. Second, the soil mixing of construction is a drilling process which is deal in noise or vibration sensitive area. For the dynamic compaction, ground vibration including by dynamic compaction can travel significant distance from the point of impact, thus limit the use by dynamic compaction to lightweight temper and low drop height of urban environment. Third, deep soil mixing use the in situ soil, making the method more economical than removal and replacement. For the dynamic compaction, a working platform be required above very loose deposit. The working platform also function to reduce the penetration of the temper. The cost of working platform can add significant cost of the project. Lastly, advantage of soil mixing. This method is primarily used to improve soil cohesive and loose to medium density cohesiveness soil. For the dynamic compaction, the ground table should be more than 6.5 feet below the existing ground surface to prevent softening of the surface soil and to limit the potential of the temper thickening of the soft garden.
Innovation for soil mixing. First material that we propose to strengthen the concrete is by using fly ash. Strength in concrete depends on many factors, the most important of which is the ratio of water to cement. Good quality fly ash improves workability, or at least produce the same workability with less water. The reduction in water leads to improved strength. Advantage of fly ash to fresh concrete. First, improved workability. The spherical shaped particles of fly ash act as miniature ball bearings within the concrete mix, thus providing a lubricant effect. Second, decreased water demand. The replacement of cement by fly ash reduces the water demand for a given slab. Third, reduce heat of hydration. Replacing cement with the same amount of fly ash can reduce the heat of hydration of concrete. Advantage of fly ash to harden concrete. First, increase ultimate strength. The additional binder produced by the fly ash reaction with available lime allows fly ash concrete to continue to gain strength over time. Second, reduce permeability. The decrease in water content combined with the production of additional cementitious compounds reduce the pore interconnectivity of concrete, thus decreasing permeability. Third, improve durability. The decrease in free lime and the resulting increase in cementitious compound combined with the reduction in permeability enhance concrete durability.
Okay, so for the next innovation for soil mixing is rice husk ash. In the future, the availability of rice husk ash as a replacement for fine aggregate can be used if the properties of rice husk ash concrete are similar to standard concrete. Okay, rice husk ash decrease the workability of concrete as the water requirement increase. But if we use rice husk ash with some steel fiber, it will increase the strength of concrete, hence can be used as a normal concrete in the future. So the advantage of rice husk ash provide good compressive strength to the concrete. It is a byproduct, hence it helps in cutting down the environment pollution. Okay. Next, the density of concrete containing rice husk ash is similar to the normal weight concrete. Hence, it can also be used for the general purpose application too. Rice-wool concrete has good shrinkage property and increase the durability of concrete. The technical and economic advantage of incorporating rice-wool ash in concrete should be exploited by the construction and rice industry, more so for the rice-growing nation of Asia.
Lastly, the innovation of soil mixing. Oil palm tongue fiber was used to improve the properties of cement composite. It was found that increasing in oil palm tongue fiber content up to 13% increase the compressive strength and decrease the density of cement composite. The study also found the additional of excessive of oil palm tongue fiber in content composite decrease the compressive strength and continue to increase the water absorption and moisture content has decreased the density. Okay, the advantage of oil palm tongue fiber. Firstly, the effect of different volume percentage of oil palm tongue fiber on the physical, mechanical, durability properties of grade 13 concrete. Next, oil palm tongue fiber was found to possess high tensile strength, high density, and high content of lining. Lastly, oil palm tongue fiber is suitable as reinforcement. The compressive, tensile, and fractural strength properties of the concrete improved by the addition of 1% oil palm tongue fiber, and the oil palm tongue fiber have act as crack arresting.